Today we're going to dive into the world of numbers, and we're going to learn about two completely new kinds of numbers, and they are binary and hexadecimal numbers. Now, as a warm-up for this class, we're going to talk about what are binary and hexadecimal numbers. Now, don't be afraid of the long words. They're actually rather simple and the same as the numbers we see every day. So the numbers we use in our everyday lives are called decimals, right? So, 102, these kinds of numbers, they are called decimals. And the reason why they are called decimals is because they are actually represented by 10 different types of numbers. So dec means 10, and they are represented by 10 different numbers, which are 0, 1, 2, all the way to 9. 10 numbers represent these decimal numbers. So as you can see from this example here, this is a decimal number because it is represented by 10 numbers, okay? So 102 is a decimal number. All these are decimal numbers, and all decimal numbers can be represented by 10 numbers. Binary numbers, on the other hand, are represented by two numbers, only ones and zeros. And that is why it is called binary, because it is represented only by a 0 and 1. Binary numbers can only include zeros and 1 in it. Cannot have 5s, cannot have 6. It can only have zeros and 1s. And bind, of course, is 2. And for hexadecimal numbers, it is the same logic. It is represented by 16 numbers, 0 to 9. It can also be represented by A's, B's, C's, D's, E's, and F's. And A means 10, B means 11, C means 12, D means 13, E means 14, and F means 15. So it all follows the same logic, and that is how many numbers represents these numbers. So binary numbers are represented by two numbers, zeros and ones. Decimal numbers are represented by 10 numbers, zeros to nines. And hexadecimal numbers are represented by 16 numbers, which are 0 to 9, and then A, B, C, D, E, F. All right, with that in mind, let's take a look at what we will learn in this class. In this class, we will learn about how you can switch numbers between binary decimals and hexadecimals. And what does that mean? So if I give you any number, whether in binary, in decimal, or hexadecimal, you will know how to write that number in a different time. For example, if I give you 10 as a decimal number, you will know how to represent 10 as a binary number and how to represent 10 as a hexadecimal. All right then, so further ado, let's just run straight in. So before we talk about specifically how we switch these numbers from binary to hexadecimal or hexadecimal to binary, let's take a look at how the numbers we see every day are presented. So we know that the numbers we see every day are decimal numbers because they are presented from 0 to 9. So let's just say a number like 491. What specifically does this number mean? If we go to the essence of it, 491 actually means 4 times 100, which is 10 to the power of 2, plus 9 times 10 to the power of 1, plus 1 times 10 to the power of 0. This is what this number actually means. And this is the way we present all kinds of numbers. From binary to hexadecimal, it's the same thing. Now, let's apply the same logic to this number below here, which is a binary number as we've seen. It can only be represented by two numbers. This number 1011, we know that it has 4 spaces. Essentially, what it means is 1 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. This is what this number means. Let's take a look at this hexadecimal number. It's the same thing, but to the power of 16. Sorry, this is the power of 2. I didn't mean power of 3. pretty badly written, but for hexadecimal numbers, it's the same thing as decimal numbers, as uh, binary numbers. The only difference is that it's to the power of 16. It's 16 to the power of its position, not 10, not 2. So this A means 10, right? Basically means 10 times 16 to the power of 2 plus 1 times 16 to the power of 1 plus 2 times 16 to the power of 0. So we see that all numbers, no matter if you are decimal numbers, binary numbers, or hexadecimal numbers, they're all presented in a similar fashion. And that is, you have, it is basically timing to the power of something, right? And we'll use this pattern to switch numbers between different types. Now let's look at specific examples. We're going to first look at how you can present a binary number as a decimal number, how to switch them. So if I give you a binary number, for example this, which is presented only by zeros and ones, how you switch it is by taking each unit of the number and timing it by 2 to the power of its position. So we know that, so what is my meaning by its position? So first, let's take a look at this example here. The first thing you want to do is mark the position of each unit or each digit. The digit starts from 0, and you want to start from the right end, so from the smallest digit. This digit is called 0. And next, the position is 1, next the position is 2, next this position is 3, the final one position is 4. Right? So you just mark this up accordingly. So you mark its position. The next thing you want to do is take each unit of the number and times it by 2 to the power of its position. So you want to take the digit 1 here, you want to times 2 to the power of 4. And you want to plus by 0 times 2 to the power of 3. And you want to repeat this process until you have used up all the units, right? And then you will get the decimal representation of it. So you want to just add all of these expressions together and you will have the decimal representation. You want to add 1 times 2 to the power of 4 plus all of these plus together, you will get the decimal representation. So let's take a look at another example. Pause the video right here, work it out by yourself, or try yourself, and then see the solution. All right? Now, first thing you want to do is mark the positions that we have done last time. So let's mark it 0 at the rightest end, and then 1, 2, and 3. Next thing you want to do is take each unit of the number and times it by 2 to the power of its position. So 1 times 2 to the power of 3 plus 0 plus times 2 to the power of 2 plus 0 times 2 to the power of 1, and then plus 1 times 2 to the power of 0. So this, if you add all of this together, which is 8 plus 0 plus 0 plus 1, then we know that this binary number is actually equal to what we say 9. All right? So this is how you switch binary numbers to decimal numbers. Now let's look at how you switch hexadecimal numbers to decimal numbers. It is actually the same logic as last time. It's basically the same thing as what you do when you switch binary numbers to decimal numbers. You take each unit, you times it by 16 to the power of its position. So pause the video right now as before and try this problem yourself before seeing the solution. All right? Okay, let's take a look at the solution here. First thing you want to do is, as the same as last time, mark the position of each digit. So starting from the right side, 0, 1, 2, and 3 for this number. And then you're going to take each digit or each unit and times it by 16 to the power of its position. A, which is equal to 10, 10 times 16 to the power of 3 plus 1 times 16 to the power of 2 plus 2 times 16 to the power of 1 plus b is 11 times 16 to the power of 0. And you add all of this together, you'll be able to represent this hexadecimal number as a decimal number. All right. Now let's look at how you switch a decimal number to a binary number. This is a little bit different than what we have seen last time or before. And the reason why I want to tell you about a different sort of method because it is so fast and so easy. So what you do with this method is you divide the decimal number you want to switch to binary by 2 again and again and again. You take the remainders and you flip it. I'll show you what I mean by using an example. For example, if I want to switch the number 12 in decimal to a binary number, what I do right here is I divide it by 2. Or I don't really want to use it this way. We want to divide sort of like using this. So I divide it by 2. I will get the 6. And the remainder of 12 divided by 2 we know is 0, right? And then we want to divide it by 2 again. We'll get the number of 3. Remainder is 0. We divide it by 2 again. We get the number is 1. The remainder this time is 1 because 3 divided by 2, the remainder will be 1. We will divide 1 by 2 again. The number remaining will be 0 and the remainder will be 1. So this is what I mean by repeatedly dividing the number by 2 again and again and again until the number reaches 0. Then you flip the remainders. So you flip from before it's top from down, you flip it. So you will get that this number represented in binary is 1100. So this is a very quick and simple method to switch decimal numbers to binary extremely quickly. All right, so pause the video as before and try this problem down here. Okay, let's take a look at the solution now. So again, we just divide the number by 2. It's as simple as that. We just divide the number by 2 again and again. We take the remainders on the right here and until we reach 0 as shown here. Then we flip the number, and here of course we don't need, it doesn't even matter we flip it, but we get the answer is 1111 expressed in binary. Right, so that is how you switch decimal numbers to binary numbers. I do suggest that you guys watch this video multiple times to get a deeper understanding because this chapter does require quite a bit of practice. All right, so but anyway, let's take a look at how you can switch hexadecimal numbers to binary numbers. Now this again is quite a little different to the things we have done before. Now, what you want to do here is you want to switch each hexadecimal digit to a 4-unit binary number. Let's take a look at an example first. Say we have a number 9AB. We want to switch it to a 4-unit binary. What we do is we take each unit or each digit in a number, in the hexadecimal number, and we switch it into a binary number, right? We change 9 to a binary number, A to a binary number, and B to a binary number. And we use the method we just talked about, right? We just talked about. So how do we switch 9 to a binary number? We divide by 2, right? We get 4, 1, 2, 2, 0, right? So we just do this. Yeah, so we get 9 is 101 in binary. A, I'm just gonna write it, is equals to 110, right? So we just B is 111. Okay, so we got these 3 binary numbers, But now we have to make them into 4 units of binary in order to make it work. And the reason for this is because we have to make it into 16. Now, don't really care about it, but just make it into 4 units of binary. Now we only have 3 units for each number, right? We want to add a 0 to the left here until it becomes 4 units. So let's say we have number like 80. So let's try it again with the number 80. If we switch 0 to a 8 and 0 into binary numbers, 8, I'm going to write it is equal to 100. So as before, in order to make it into 4 units of binary, we add a 0 to the left. 0 in binary is also just 0. In order to make it 4 units, we just gotta add 3 zeros to the left. We just fill as many zeros as we need until we make it 4 units. And we put it together, and the binary expression will just be 0, 1, 0, 0, 0, 0, 0. This will be the binary expression of this hexadecimal number. Okay. Now, let's take a look at the last type of actually what we need to know about for this chapter, and that's how to switch binary numbers into hexadecimal numbers. So previously we have learned how you switch decimal numbers to, you know, oh no, how you switch, decimal numbers to binary numbers, how you switch binary numbers to hexadecimal numbers, how you switch hexadecimal numbers to decimal numbers, how you switch hexadecimal numbers to binary numbers, and now we're going to learn how you switch binary numbers to hexadecimal numbers. So how you switch it? So when we switched hexadecimal numbers to binary numbers, we took each digit of the hexadecimal number and we made it into 4 units of binary. Here, we do the exact reverse of what happened. We group the binary number into groups of 4s and we switch it into 1 unit or 1 digit of hexadecimal. Say we have the binary number of 101,001. See here. How we switch it into hexadecimal is by grouping it into groups of 4s. So let's say here, we make it into groups of 4s. All right. And then we switch each group into 1 hexadecimal number. Now, how you make it into a hexadecimal number is by just making it a decimal number. Say this is 0011. We talked about how to switch to a decimal number is by first marking the position and timing it by the power 2 to the power of its position, right? So let's mark the position first here, and this number will be equal to 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. And this number will be equal to 3. This number will be equal to 9. Right, so this switch to a decimal number will be equal to 9. This switch to a decimal number is equal to 3. You put them together, the hexadecimal representation of this number here will be equal to 93. So how about the number of 101? It is not enough to group into groups of 4s, right? What you do is the same as before. Add a unit of 0 to the left until you have enough of groups of 4s. So we just add a unit of 0 to the left, and we switch this group of 4 to a decimal number. How about you have the number 10101, right? If you group it into groups of 4, this is a group of 4. You want to add zeros to the left as much as needed to make groups of 4s. All right, so take a look at the final one, and it's how you switch decimal numbers into hexadecimal numbers. Now, this is a bit tricky because you can't really do it directly. The only way you do it is by switching the decimal number into a binary number first, and then switching the binary number into a hexadecimal number. But you don't really need to know about this method. So if you don't want to learn it, it's fine as well. It won't appear on your test. It's not required, but if you are interested, the way you do it is through this two-step method. Look at this example. If you want to switch the number of 10 in decimal to hexadecimal number, this is quite a simple quite a simple demo, but so first you want to switch it to a binary number because we know that binary numbers can be switched into hexadecimal numbers directly. We have learned it in here, binary to hexadecimal. So first we want to switch 10 into a binary number. So 10 divided by 2, just we use the method we learned before, keep dividing until we hit 0. Right, so we just 2 divided by 2 equals to 1, remainder 0, and then divided by 2 again, 0 and 1. So we have the number of 1010. We want to switch this binary number to hexadecimal now. This is able to do. So we have learned that in order to switch a binary number into a hexadecimal number, you group it into groups of 4s, and you switch each group of 4 into a single decimal number, and that decimal number can be represented as a hexadecimal number. And the way you switch binary to decimal numbers is by first marking the position, then timing each digit by 2 to the power of its position. So here it is equal to 1 times 2 to the power of 3 plus 1 times 2 to the power of 1, which is equal to 10. And then we represent 10 as a hexadecimal number, so we know that 10 is equal to 8. Right? So then we know that 10 represented in hexadecimal is equal to 8. This is a simple demo. If you say you have a number of 101, you switch it, and decimal number, you want to switch it to hexadecimal, you say use the same process. You change 101 into a binary number first, and then you switch that binary number into hexadecimal directly. All right, so that's it for this class. In this class, we have learned is how to switch numbers between decimal numbers, hexadecimal numbers, and binary numbers. Make sure to do lots of practice because it is easy to forget the numbers, the methods I have taught you in this class. It's quite a compact class, so make sure to revise as well. That's it. Peace. See you next time.